Good afternoon, fifth grade friends. I am Mrs. Matani, and I'm so excited to be back with you all today. On Monday, we continued with algebraic expressions and order of operations, and so we're going to do that again today. So let's take a look at our smartboard. Our two objectives for today is writing simple expressions that record calculations with numbers and interpret those expressions without evaluating them. If you remember on Monday, I gave you an expression of words and you were supposed to write that out to see if we could check it today. So we're going to do that in just a moment. And then take a look at this. Generate two numerical patterns using two given rules. Identify relationships between corresponding terms. So today we're going to move a little bit forward with our algebraic thinking. All right, so I told you all that I would have a brain teaser every single time I came. So today is no different than Monday. Here is your brain teaser for today. I want you to write a numeric expression based on this. I'm going to read it to you guys. It says, Robert is 20 years old. His brother is 2 years less than half his age. How old is Robert's brother? Now remember, I don't necessarily want you to tell me how old his brother is. I want you to create an expression based on these numbers that you see. So I'm going to give you just a few seconds to do that, and then we're going to check it together. When you look at this, I see some key words. I'm going to underline these key words before we actually write the numeric expression. So I see that Robert is 20. So that's my key number right there. I also see that his brother is 2 years less. So I see less. So in my mind, the word less, I automatically think of subtraction. 2 years less than half. When I see the word half, I think of a fraction, his age. So Robert is 20 years old. I can see 20 in my brain. His brother is 2 years less than half of. Now, that can be confusing because you might want to go ahead and subtract 2 from 20. But if you really look closely, here's what those words and numbers say. Robert is 20 years old. His brother is 2 years less than half of Robert's age. So I see that I need to half Robert's age first. Anytime that I'm working with multiple numbers in an expression, I put parentheses around the first thing that I'm doing. And the first thing I'm doing is half of 20. Half of 20 can look like this. Half of 20 can look like this. I'm going to use this one because that's what's spoken. Half of 20. Then Robert is 20 years old. His brother is 2 years less than half of 20. Did anyone out there do this? If you did, that's okay, but that's not really what it says. It says half of. And when you hear that word of, when you are in math, that means to multiply. So he is half of 20. But let me ask you this. Is half of 20 the same thing as 20 divided by 2? Yeah, it is, isn't it? Because half of 20 is 10, right? And then 20 divided by 2 is also 10. But this one right here, this expression, that is the correct expression. So how'd you do? Were you able to solve the brain teaser? Now, when we left off on Monday, I gave you one statement. And this statement here says 2 times the sum of 5 and 6. And I asked you to work on that for me and bring it to this lesson today. So let's look at that. Let's look at the key words. I see 2 times, and then I see the sum of. Most of the time when you see something times the sum of or something divided by the sum of, when you see the sum of, most of the time that means it's already been done. So in this case, 2 times something that has already been done. So if it's already been done, that means we need to do it first. So we have to look for key words. So in order to solve this, I need to make sure I write the numbers in the correct order. 2 times the sum of 5 and 6 means I've got to find 5 and 6, the sum of that, before I multiply. Remember, the only way that you can add or subtract before you multiply or divide in an expression is if you put it in parentheses, because those parentheses means to do it first. So is that what you got for that expression? All right, let's go to the next one and see what we have here. 1 less than 30 divided by 5. Again, let's look at some key words. I see 1 less. So when you think of less, I automatically think of subtraction. Then it says less than 30 divided by 5. That's really easy because you see that ED. It's already been done. That's a clue that 30 has to be divided by 5 first before we can subtract the 1. So if I see this, I'm going to start with what's done in the past, what was done first. 30 divided by 5, right, minus 1. Now let's look at that for just a second. Would I need to put 30 divided by 5 in parentheses? No, I wouldn't, because multiplication and division come before addition and subtraction in expressions. Most of the time, I still like to put parentheses just so I'm reminded it comes first. But you don't necessarily have to, because multiplying and dividing is before adding and subtracting. So either way is fine for this particular one. This one we had to put parentheses. All right, what about half the sum of? Again, I hear key words. I hear the sum of. The sum of means it's already been done. So half of what's already been done. So half the sum of 18 and 12. So 1 half the sum of 18 and 12. Remember what I said about multiplying on Monday with parentheses? You can either put the number right next door to the parentheses, because that means to multiply, or you could put a symbol. There are 3 different symbols that we have for multiplication. You could put the regular multiplication sign, but do you remember the other signs that you could have? You could have a dot, or I even sometimes put a little bitty star. That star also means to multiply. So we could write it as half of the sum of 18 and 12, or we could put a multiplication sign, or a dot, or even just have it right next door to the parentheses. All of that means the same thing. All right, let's look at this last one. I want you to do this one without my help before we move forward. 3 times the difference of 12 and 9. I see keywords. What are keywords that you see? You see times, And you see difference, yeah. And when we see difference of, that means it's already been done. It's the difference of what happened. So here we have 3 times the difference of 12 and 9. You could say 3 times 12 and, whoops, sorry about that, and 9. But notice, because 12 and 9, we have to find their difference before we multiply. What must I do right here? Yeah, I have to put parentheses around it. That way I know I do it first. I want you to go back up here for just a minute. Notice I have this written differently. 2 times the sum of 5 and 6. I said 5 and 6 times 2. That's still correct. But if I'm doing it just as I see it, I probably should have put 2 times 5 and 6, the sum of 5 and 6. Either way, they're both still correct as long as you find the sum before you multiplied. So again, this is what we worked on Monday, and I just wanted to wrap that up today as well. All right, so now we're going to move forward to today's lesson. Today is all about patterns, and I love this particular standard because it's really easy for kids to get, and I love looking at mathematical patterns. If you think about it, math, boys and girls, is all about patterns. Think about when you add, when you multiply. Multiplication is just repeated addition. When you subtract and divide, division is repeated subtraction. I love, love, love math for that purpose right there. It's really cool to find patterns. So I want you to look right here at the next 3 numbers in each pattern. Let's see what we can find. Let's look at the first pattern. Do you know what the next number would be in that pattern? Let's take a look. 0, 4, 8, 12, 16. What would it be? Yeah, that's right. It'd be 20. What would be the next number after 20? 24, and then 28. If I asked you to tell me a rule for that pattern, what did you follow each time to figure out your answer? Did you add 4 each time? Because that's what I did, yeah. So add 4. Let's look at this pattern. What would you do to get the next 3 numbers with this pattern? 2, 8, 14, 20, 26, 30. Good. Yeah, 30. Then, oh wait, sorry. Wrong one. 32. Sorry about that. Whoops. What's after 32? 38, and so on. What was our pattern there? What's our pattern there? Add 6. Look at this pattern here. What do you notice about this pattern? It's the opposite of what we've been doing. This pattern you are subtracting. Yeah. 28, 24, 20, 16, 12. What would be next? 8. Yeah, and so on. Notice we are subtracting 4. So that's easy. Quick, easy patterns with adding and subtracting. Today, let's take a look at the few terms I want you to focus on as I teach through today. Pattern, which is what I just talked about. It's a sequence of numbers or shapes that follows a specific rule. Skip counting, adding 4, subtracting 4, multiplying by 2. Okay, so there's patterns, and we see patterns all the time, not just in math, but everywhere throughout the world around us. Terms. Terms are the numbers in a pattern. So if I use the word terms today, that's what it means. The rules. Rules tells you how to move from one term in a pattern to the next, right? And then what we just saw in those patterns, we had rules. Add 4, add 6, subtract 4. And then corresponding terms. So these are the two I really want to focus in on today. Terms and corresponding terms. Corresponding terms are terms that are in the same position in two related patterns. So we're going to take a look right now at some different patterns. All right, let's look at this one. This is a table that simply shows you yogurt cups and the total cost of the yogurt cups. Obviously, if there are no yogurt cups, then there's no cost. Those terms are 0 and 0, and they go together because 0 yogurts makes $0. 0 and 0 go together. Here, if I have 1 yogurt cup, how much does 1 yogurt cup cost? $3. So those terms, 1 and 3, go together. They correspond together. 1 corresponds with 3. 1 yogurt cup for $3. 2 yogurt cups. How much would 2 yogurt cups be? $6, yeah, because we're going to add 3 each time. So 2 yogurt cups makes $6. I want you to look at the rest of this table, and I want you to think about how much it would cost for 3 yogurt cups. Notice our rule is to add 3. That's right, it would be $9 because we're adding another cup of yogurt that costs $3. So it would be $9. And so those corresponding terms, the terms that go together is 3 and 9. What about 4 cups of yogurt? How much would that cost? Yeah, it would cost $12. That's exactly right. So those terms go together as 4 and 12. So the rule was add 3. And our terms that went together were based on that rule. So easy. Patterns in math, so fun. All right, let's look at these. What if I had a cost of 2 different items? French fries and hamburgers, yummy. If I have 0 hamburgers, I'm going to have a 0 here. If I have 0 French fries, I'm going to have a 0. What if I have 1 order of French fries? What would that be? What would that look like? I'm going to show it well. Yeah, it'd be, that doesn't show it very good. Let me try this color. That's better. It would be $5. And notice that 1 hamburger is $7. 2 items of French fries would be $10. Can you tell me what 2 orders of hamburgers would be? Yeah, that's right, it'd be $14. What about 3 orders of French fries? 0, 5, 10. If our rule is to add 5, what would be the next number? Yep, 15, that's right. What would be the next number of hamburgers? 0, 7, 14. What would be next? Yeah, 21. Tell me, or a parent actually, or a guardian, or a brother or a sister if you're watching together, what this next one would be. What would be the cost of 4 orders of French fries? Yes, it would be 20, that's correct. Again, our rule was to add 5 each time. And if you think about it too, multiplication, repeated addition, if I have 4 orders of French fries and each order is $5, 4 times 5 is 20. Same thing for hamburgers. If the rule is to add 7 each time, repeated addition, then 7 times 4, take a look, is 28. All right, let's take a look at one last chart. We're going to apply what we've just learned by looking at 2 different tables. Again, remember, we're looking for terms and corresponding terms. Terms are the numbers in our pattern, and corresponding terms are the numbers that go together. So here it says, can you compare the cost of a number of square feet of tomato plants and the cost of the same square footage of pepper plants? All right, so I'm visualizing tomato plants and pepper plants, and I'm looking at them and looking at how much each would cost and the square footage that they would cover. If there's no square feet, that means there's no tomato plants and there's no pepper plants. But what if there's 1 square foot? Tomato plants would cost $3 and pepper plants would cost $6. So these corresponding terms right here would be 3 and 6, 3 to 6. If there are 2 square feet, 5 and 10. Are you seeing a pattern? What about 3 square feet? 3 to 6, 5 to 10. What would that pattern be? I'm seeing halves. 3 is half of 6, 5 is half of 10. So what would be half of 14? That's right, it'd be 7. And so 7, 14, those are the corresponding terms. What about 9? 9 is half of what? What would 9 be half of? That's right, 18. So those corresponding terms are 9 and 18. So do we now see a pattern? Do we know a rule? If so, can you do this last section here? We can look at different patterns across for tomato plants and also across for pepper plants and also going down. So 3 is half of 6, 5 is half of 10, 7 is half of 14, 9 is half of 18, 3, 5, 7, 9. What would be next in those terms? Yeah, it would be 11, and that's so hard to see, and I'm sorry about that, but that's 11. 6, 10, 14, 18. What would be the next? Yeah, 22, that's right. So notice that this right here has lots of different patterns. You can find different rules, and you see all the terms. Remember, terms are numbers, and you see corresponding terms. These match with each other. That's what corresponding means. They go together with the pattern. So these corresponding terms are 11 and 22. I told you this was easy, and it's fun. I love patterns in math. All right, take a look at your exit ticket before we go really, really quickly. Mary writes a number pattern. She uses the rule add 3. She starts at 23. I want you to write the next 5 terms, remember that, in her pattern. When we get back together on Monday, I'm going to check your exit ticket with you. So you need to make sure you hold on to this over the weekend so that we can check this together. Okay? And last but not least, I did not receive one brain teaser from anybody out there. I'm very upset. I said email me brain teasers or email me ideas, so please do that. My email address is kmatani@mcpss.com. Also remember that we have our hotline for anybody that has any trouble. Maybe you're having trouble logging onto the internet. Maybe you're having trouble with math. Call our hotline and someone will talk to you, okay? 221-7777. And don't forget, you are smart, You are capable and you are getting closer to being ready for 6th grade.